When preparing for the TEKS test, use the following information to answer questions 1 and 2. Over the last several decades, Texas has used several different combinations of letters and numbers to create license plate tags. One old system used 6 characters in the following order: letter, 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 number, number, number. The newest system of generating license plate tags uses 7 characters in the following order: letter, 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 number, 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 number. Under both systems, the state of Texas does not include vowels when creating license plate tags. So we know that our vowels are A, E, I, O, U. So then when it tells us or asks us how many plates were possible under the old system, we're looking here. We know that there's 26 letters in the alphabet, but because we're excluding vowels, it's 21. So I'm going to take 21, 21, and 21, or 21 to the third. For the numbers, this is the digits 0 through 9, which gives you 10 options. So I'm going to take 10 times 10 times 10, or 10 to the third. When I type that in my calculator, it gives me this answer. How many more license plate tags were created under the new 7-character system versus the old 6-character system? So because it wants to know how many more, we have to find the new system and subtract the old system. So for the new system, it's still letter, letter, letter. So we said that's 26 minus the 5, which is 21 to the third. But now it's number, 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 number. So 10 to the fourth. That gives me this total. So when I take this total, subtract the other total, this is your final answer. Use the following information to answer questions 3 and 4. In a movie theater complex, different screens have different sizes and aspect ratios to allow the theater to show movies that were filmed with different aspect ratios. 2 common aspect ratios that have been used in the film industry since the 1950s are 1.85 by 1 and 2.35 by 1. In particular, movie theater complex, one theater has a 60-foot screen with an aspect ratio of 1.85 by 1, and a second theater has a 60-foot screen with an aspect ratio of 2.35 by 1. Find the dimensions of each screen in this theater complex, then determine which screen has a larger area. So when it's only giving us one dimension, it's important to remember that that dimension represents the diagonal. And because it's giving us the aspect ratio, this side is 1.85x, and this side is just x. So, to figure it out what these sides are, we need to find x. So we use Pythagorean Theorem. We take 1.85x and square it, plus this x and square it, and it equals 60 squared. So when we square these numbers, we get 3.4225x squared plus x squared equals 3,600. We combine these like terms to get 4.4225x squared equals 3,600. We divide by the coefficient and get x squared equals 814.019. To get rid of the squared, you square root both sides. So x equals 28.53. Normally, anytime you square root, you have to remember the plus or the negative. But because our distance, this represents a side length, you can't have the negative answer. So that's the only solution. But it's not asking for x, it's asking for the dimensions. So for this TV, this side is 28.53. To find the other side, we take 1.85 times the 28.53, and we get 52.78. It also wants us to find the area. So to find the area of this screen, you multiply the length times the width. So I'm going to multiply 52.78 times 28.53. And I get 1505.81 feet squared. Now let's look at our other screen. Again, the diagonal is the 60, but now our ratio is 2.35 x by x. So we use our Pythagorean theorem, 2.35x squared plus x squared equals 60 squared. 2.35 squared is 5.5225x squared. Combine your like terms. Divide by the coefficient. So you get x squared equals 551.936. The final step is to square root both sides. So we get 23.49 as our x. So when we plug it back in, this side is 23.49. To get the other side, 2.35 times the 23.49, and we get 55.20. To find the area, we multiply those two side lengths together, 55.2 times 23.49, and we get 1296.65 feet squared. If a movie theater filmed with an aspect ratio of 1.85 by 1, as shown on the screen with an aspect ratio of 2.35 by 1, would it be better to pillar box or letterbox the image? So I need to visualize this image. So the screen is 2.35 by 1. And the image is 1.85. So it's going to have the same height, but it's going to be smaller. So because of how I drew my image, you would want the black on these sides. And those are like pillars, so that is called pillar boxing. Remember, the rule of thumb for estimating crowds is that each person occupies 2.5 square feet. Use this information to estimate the crowd on the floor at a rodeo concert for Mary J. Blige. The floor is in the shape of a semicircle off of the stage, which is 76 feet in diameter. Round your answer to the nearest 10 people. So to find this, I need to find the area of a semicircle. So to find the area of a semicircle, we take pi r squared divided by 2. Now, I don't know what the radius is, but they told me that the diameter is 76. So to find the radius, I just divide that by 2, and I get 38. I plug that into my formula. A equals pi times 38 squared divided by 2. Equals pi times 38 squared divided by 2. and we get an area of approximately 2268.23. And then each person occupies 2.5, so I need to divide this by 2.5. And we get 907.292. Well, you can't have 0.292 people, and it wants us to round it to the nearest 10 people. So the nearest 10 people would be 910 people. You would round it up. Your grade in AQR is determined by a weighted average. Test and major grades are 50%, alternative assessments are 30%, and daily grades are 20%. Travis's average for each category respectively are 75, 90, and 92. What is his overall average? So you turn this into a decimal, 0.5, and you multiply it by what its average is, which is 75. Plus, turn this into a decimal, so 0.3, times whatever his average is, which is 90. Turn this into a decimal, 0.2, multiply by what his average is, 92. So when you multiply and add 0.5 times 75 plus 0.3 times 90 plus 0.2 times 92, we get a final grade of an 82.9. Travis wants to improve his grade in the quickest way possible, so he decides to convince his teacher to either let him retake one of his tests to raise his test average to at least an 80. So instead of this 75, it would become an 80. Or redo 4 of his 10 daily grades to raise his daily average to a 97. Which choice would have the greatest impact on his overall average? So here he's going up 5% for tests, or he could go up 5% for daily grades. Because tests weigh more than daily grades, redoing the test would impact his grade more. Because it has a higher percentage rate. Determine whether the following situations would require calculating a permutation or a combination. So remember that permutations assign spots, combinations are just groups. Okay? So selecting 6 players to be on a kickball team. You're not assigning specific people, so it's just a combination. Selecting an MC and an announcer for the senior awards banquet and awards program. You are assigning certain positions, so it is a permutation. Assigning students to their lockers the first day of school. You are assigning each student with a specific locker, so it is a permutation. A choir director must choose a 5-member vocal ensemble from a chorus of 30 singers. 8 sopranos, 10 altos, 8 tenors, and 4 bass. Each ensemble must have 2 sopranos, 1 alto, 1 tenor, and 1 bass. How many different ensemble possibilities can the director create? So the first thing is, out of 8 sopranos, you need 2. So because it's just picking 2 randomly, it's not assigning, first soprano and second soprano, or top soprano and bottom soprano. It's just a group of 2. This is a combination. So out of 8, you are picking 2. Times, you also need 1 alto out of 10. So there's 10 options there. Times, you need 1 tenor out of 8. So there's 8 options. And then you need 1 bass out of 4. So there's 4 options. So your final answer when you type this in your calculator. And to do combinations on your new calculator, you go to the screen, you click Menu, Probability. This is a combination, and it's 8, 2. So that's 28 times 10 times 8 times 4. 28 times 10 times 8 times 4. And we get 8,960 total possibilities. You can put together an outfit which consists of 3 pieces, a top, a bottom, and shoes. You have a skirt, a pair of pants, and a pair of jeans for the bottoms, so that's 3 options. You have 2 long sleeve shirts, 1 button-down shirt, and 1 hoodie for the top. So 2, 3, 4 options for the top. And you finally have black boots, brown boots, purple tennis shoes, canvas sneakers, and gray suede slip-ons. So that's 5 options for the shoes. Assuming all the pieces coordinate, how many outfits can you create? Multiply them all together, and you get 60. A high school swim team has 14 members, 8 boys and 6 girls. If the team will compete in a 4-member relay, how many ways can the 4-member team be chosen? Because it's a relay, you're assigning specific players to go in a specific order. So that tells you it's going to be a permutation. So we have 14 total members, and we are selecting 4 of them. So when I type it in my calculator, 14, 4, you get 24024. If the boys team, so now we're only considering the boys, which is 8 of them, compete in a 4-member relay, how many ways can the 4-member team be chosen? So again, you're assigning each person a specific order because it's a relay, so it's a permutation, and we're selecting 4 people. So we do Menu, Probability, Permutation, and it's 8, 4. 1680. If the girls take gold, silver, and bronze in the 100-meter freestyle, how many ways can the medals be awarded for the team if all the girls on the team participated in the event? So you're only looking at the girls, 6. We're assigning a specific award to each one, and there's 1, 2, 3 awards. So Menu, Probability, it's a permutation. Out of 6, we are selecting 3, 120. A box contains 4 red and 2 blue chips. A chip is drawn at random and then replaced. A second chip is then drawn at random. Show all of the possible outcomes using a tree diagram. So I'm going to create my tree diagram. The first thing I'm going to do is I'm either going to draw, and it's going to be red or it's going to be blue. Now, this needs to be a weighted tree diagram because it can either be, there's a higher probability that it'll be red than it will be blue. So if it's 4 out of 6 total options, 4 out of 6, that reduces to 2 out of 3. For the blue chips, there's a probability of 2 out of 6 total options, which is 1/3. So you draw your chip, you replace it, and then we draw again. So again, you can get a red or a blue, a red or a blue. The red has a probability of 2/3, the blue has a probability of 1/3. Calculate the probability of getting at least 1 blue. So for the probability of getting at least 1 blue, here we get a blue. So it's 2/3 times 1/3. Here we get 1 blue. So it's plus 1/3 times 2/3. And here we get at least 1 blue. So plus 1/3 times 1/3. We have to include all of those different possibilities. So I'm doing 1 divided by 3 times 2 divided by 3. Just again. 1 divided by 3 times 2 divided by 3. Okay, so this is 2/9. Then we also have that again, so 2/9. And then we have 1 divided by 3 times 1 divided by 3 and 1/9. So when we add these all up, 2/9, 2/9 is 4/9, plus another 9 is 5/9. So the probability of getting at least one blue is 5/9. 2 of the same color. So for this one, you're using red and red, so that's 2/3 times 2/3, or blue and blue, so plus 1/3 times 1/3. Those are your only two options. So 2 divided by 3 times 2 divided by 3 gives us 4/9, plus 1 divided by 3 times 1 divided by 3 is 1/9. So it gives us a total of 5/9. What are the odds of getting a red if you only make one draw? So only one draw, the odds of getting a red is 2 out of 3. That's the probability. The odds of getting a red is 4 reds to every 2 blue, which reduces to 2 to 1. This is the odds. This is the probability. Venn diagrams. Use the following Venn diagram to answer the questions that follow. A study was made of 200 students to determine what TV shows they watch. What's the probability of a student chosen at random only liking Tiny Toons? So we're looking at Tiny Toons, and it's only Tiny Toons, so it's 73 out of the 200 that were chosen. So 73 out of 200 does not reduce. What is the probability of a student chosen at random liking Tiny Toons? Now, it's not saying only Tiny Toons, it's all of these dots. So you have to add 73 plus 23 plus 9 plus 31. So it's 136 out of 200, which is 17 out of 25, which is the fraction, or 68%. What is the probability of a student chosen at random liking none of these 3 cartoons? That is this tiny little portion right here, 22 out of the 200. It's 11%, or 11 out of 100. Wrong spot. How many students like all 3 shows? So that's the part that's in all 3 circles, and it's the 9. What's the probability of a student chosen at random liking Animaniacs and Pinky and the Brain? Animaniacs, Pinky and the Brain, they overlap in these 2 sections. So 9 plus the 14 divided by the 200. It's 23 out of 200, or 11.5%. For a fundraiser, the freshman class constructed a maze out of a large box and sold tickets to the maze. As an incentive, prizes, a free dinner, movie tickets, or a bicycle were placed at each exit from the maze as shown in the diagram below. Study the path diagram below and construct an area model to represent the probability of winning each prize. Assume a participant can only move forward or sideways. So when I enter, I can either go up or down. So I split it in half. And then if I went up, I can either go to path A or I can go to path B. If I went down, I can either go to path C or to path D. Then, if I went to path A, I can either go straight or I can go down, so I split it in half. If I go straight, I have to end up at dinner. I'm going to use colors. If I go straight, I have to end up at dinner. If I went down, I have to end up at a bicycle. If I went down path B, I could either go straight or I could go down. If I go straight, I could either go up or I could go straight. So I split that in half again. If I go up, I have to end at dinner. If I went straight, I have to end at bicycle. If I had gone down, my only option is to end at bicycle. Through path C, I can't go up because then I'd have to go backwards. So I have to go straight, and it makes me go to bicycle. If I go down path D, my only option is movie. So what is the probability that you will receive a bicycle as a prize? The thing about area models is once they're drawn, you have to break them into equal portions. So there it is in equal portions. So the probability that you will receive a bicycle, which is the maroon, is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What's the probability that you will receive a movie as a prize? So the movie is just this yellow, and it's 1, 2, 3, 4 out of the 16 total. Or that reduces to 1/4. Study the graphs below. Decide if the graphs are appropriate or misleading. If the graphs are misleading, explain why. So this first one, it's a bar graph. It's got separated by students. The scores go from 75 to 100. So this is misleading because it doesn't start at 0. The y-axis needs to start at 0 to give an accurate representation. Okay, bowling averages. Again, bar graph, Diana, LD, and Emily. But here, it makes it seem like they're all super close, but I can't really tell how close they are because the scale is so high. So this is misleading. The y-scale only needed to go to 100. Okay, this one. So September, this is healthy food choices. So this heart is worth 4. But my hearts are different sizes. So I don't know, do these bigger hearts, are they worth more? Really, that heart's smaller than even those hearts. So this is misleading because the hearts are different sizes. Where do you spend most of your money? Okay, so I'm looking for the largest portion on here, and I can tell that for sure it's this 51%. Now the coloring makes it kind of hard to tell what exactly the 51% goes to. So if you were to look on a color copy, it'd be much more obvious that this matches up with shopping. Which combination of expenditures is about 1/3 of your money? So which combo, or by adding what pieces together, can you get to the 1/3? It's this 28% plus the 3% plus the 3% would get you to about 33%, which is 1/3. So it's just being able to read this, which because of the gray colors, it's kind of hard to tell. So this represents the bills, the savings, and the other. What is favoritism in the data collection or reporting process called? This is bias. When you favor one thing, it's the bias that you have. In which step of the 4-step statistical process is the data organized and summarized graphically or numerically? This is the process, step 3, which is where you're analyzing your data. Before data can be analyzed, a question must be formulated and data must be collected. For questions 27 through 31, label each description of the type of sampling used. Choose from a simple random sampling, stratified, cluster, systematic, or convenience. Individuals are chosen for a sample only because they are easily accessible. That is the definition of convenience. Each member of the population has an equally likely chance of being selected for the sample. So because it's every single member in that population, this is a simply random sample. The population is divided into subgroups, and then a sample is taken from each group. So as long as they are being grouped in subgroups based off of something, this would be called stratified. So for example, in our classroom, maybe I'm grouping you by averages, all the A's, B's, C's, and D's, and then sampling somebody in each of those groups. The population is divided into subgroups, and a sample is taken from some of the groups. So because now I'm only going by the location of where I've grouped you, this is called cluster. A sample is comprised of every nth person chosen from a list of individuals in the population. This is systematic. You have a system or a certain way that you are going about to select your people. Is the following Visa card number valid? Why or why not? So to calculate whether a Visa card is valid, you take the odd numbers or the odd digits. So I'm doing every other one. And you add them together. So 4 plus 3 plus 1 plus 3 plus 5 plus 7 plus 9 plus 2, and you get 34. And you multiply that number by 2, so I get 68. Then you add all the even digits. 8 plus 0 plus 2 plus 4 plus 6 plus 8 plus 1 plus 3. And I get 32. Lastly, you add all of the odd digits that are greater than 4. That's not greater than 4. That's not. This one is. This one is. And this one is. So I need to add 3. So I'm adding 68 plus 32 plus 3. And I get 103. So it is not valid because it doesn't end in 0. What would the check digit D have to be for the MasterCard number below to be valid? So I go through and I'm going to add up all my odd digits. And what that means is like this is the first digit, second, third, fourth, fifth, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th. So all of the odd digits. Don't look at the numbers, you're looking at the digits. So I add 5 plus 3 plus 1 plus 9 plus 7 plus 5 plus 3 plus 5. And I get 38 times 2, 76. Then I'm going to add all the even digits, so all the other ones. 4 plus 2 plus 0 plus 8 plus 6 plus 4 plus 4. And I get 28. And then I look at the odds that are greater than 4. So this one's greater than 4. This one's greater than 4, greater than 4, greater than 4, greater than 4. 1, 2, 3, 4, 5. I add them all together. And I get 109. So to make it end in a 0, I need to add 1. And that would get me to 110. What is the expected number of tails when flipping 6 coins? So you can expect, if you're flipping 6 coins, that half of them are going to be tails. So 3. Using a standard deck of cards, answer the following question. So remember, for a standard deck of cards, there's 52 cards with 4 different suits. What's the probability of randomly drawing a 2? So if you think about all the 4 different suits, there are 4 2s in a deck out of the 52 cards. So if I take 4 divided by 52, I get 1 out of 13. What's the probability of random selecting a black card? Okay, so that means half of your deck is black. So a 1 out of 2 chance of getting a black card. And then, so multiplying because it's and, a red card. So now you're getting a red card. There should still be half of them left, which is 26. But you've already taken 1 card away. So there's no longer 52 total. There's 51 total. So when I multiply those, I'm going to get 13 out of that 51. What's the probability of random selecting a face card or an ace? So because all of the suits are the same, let's just say that we're looking at one of the suits. So that's 52 divided by 4. So there's 13 cards in one of our suits. And then face cards are an ace. So we have Jack, Queen, King, and Ace. So that's 4 cards out of the 13. A certain carnival game costs $3 to play. The table below shows the frequency of winnings for this game. If a small prize costs the carnival $1 to purchase and a large prize costs $3 to purchase, how much profit would you expect the game to make from 150 players? Hint, profit is the money left after you buy the prizes. So first I need to find the expected payout per player. So to do that, I take the probability of the small prize. So that is 25 out of the 70 total. I add these up. 25, 35 plus 35 is 70. And those players I'm anticipating on paying $1 for the small prize. Plus, for the large prize, I'm having to pay $3, and it's 10 out of 70. I don't pay anything for the no prize. So my expected payout is 70.785, so 79 cents approximately. But it wants to know the profit. So if I'm charging $3 to play, 3 times 150 equals $450 that I'm making, but I'm paying this amount for each customer, so 0.79 times 150. And I need to subtract those two. $331.5. That is your expected profit. A 2007 CNN poll reported that 51% of Nevada voters favored Hillary Clinton. The poll indicated a margin of error of plus or minus 5%. Which of the following statements best represents what the sampling error means? So that means that with this percent, you could either add or subtract that amount. So if I take 51 minus 5, I get 46%. If I take 51 plus 5, I get 56%. So between 48.5% and 53.5% of Nevada's Democratic voters would vote for Clinton over any of the other listed Democrats. No, we said it's 46 to 56. Between 46 and 56 of Nevada's Democratic voters would vote for Clinton over any of the other listed. Yes. 5% of the people polled may change their mind before the election. No. 5% of the population couldn't be reached for a response. No. That's just the percent error. We don't know where that error came about. We just know that that is the margin of error. Lastly, we're talking about box and whisker plots. What was the highest score on the test? So looking at a box and whisker plot, the highest is right over here at 102. What percent of the class scored above a 72? So each of these parts represents 25%. This is 25%, this is 25%, 25%, and 25%. So what percent of the class was above a 72? 1, 2, 3, so 75%. What was the median score on the test? Median's in the middle. Right here in the middle is that 88. 50% is below, 50% is above. What percent of the class scored between an 88 and a 96? That's just that one little section, so 25%. What are the values of the range for the middle 50%? So the middle 50% is this box portion, so it's between a 72 and a 96. About 75% of the students scored between a 38 and a 96. 25, 50, 75. This is true. Do you think that this test was too hard for the students? Now, it's not great that we're getting a 38 over here, but at the same time, you have 75% of your students passing, and you have 50% getting above an 88. That's almost an A. So if you ask me, that's a no. Good luck on your TEKS test.